So, students, I was explaining about the metallic character. Now, metallic character depends on one very important factor, and that is your atomic radius. Now, what is atomic radius? It is the distance of the nucleus to the outermost shell. Similarly, if you go for this for hydrogen, I have written, say for lithium, it has got 2 shells. Sodium, it has got 3 shells. If you look at potassium, it has got 4 shells. So, as we observe the distance from the nucleus to the outermost shell, as we move down a group, it keeps on increasing. So, distance has become more, due to which the force of attraction between the nucleus and the outermost electron becomes less. This less force of attraction or interaction makes the metallic character increase as we move down a group. Why increase? Because metallic character depends upon the number of electrons, either the number of electrons which can be lost or which an element uses to complete its outermost shell. So if you find that potassium will have a tendency to lose it much more easily as compared to that of lithium or hydrogen. So what happens to metallic character as we move down a group? It increases. And across a period, it decreases. Metallic character means electropositive character. Now let's talk about the non-metallic character. It should be the opposite of metallic character. Non-metallic character increases as we move. Increases. Metallic character increases as we move down a group. Non-metallic character will decrease as we move down a group. Metallic character decreases as we move across a period. Non-metallic character will increase as we move across a period. So this part you better be clear. Now non-metallic character is also electronegative character. If they ask you what happens to the electronegative character as we move across a period, think same like non-metallic character. Non-metallic character increases, electronegative character also increases. What happens to electronegative character as we move down a group? Electronegative character is non-metallic character. Non-metallic character as we move down a group, it decreases. Same goes with electronegative character. As you move down a group, it will decrease. So which is the most electronegative element? If it is asked, fluorine. Second most, oxygen, remember. And third, chlorine. So keep this in mind. This is about your metallic characters and non-metallic characters. Let's take one few examples just to understand our topic for today. Say, if a configuration is given, say any element X has any electronic configuration, maybe say 19, and you are going to specify which period and which group it is going to remain. So what do you do? First, of course, 19, in this case, if you look, it looks like potassium, but let's leave it. We'll first write down the configuration. So 2, 8, 8, 1. It has got 1 electrons in the outermost shell. So which group has got 1 valence electron? Group 1. So it will remain in group 1. How many shells are there? K shell, L shell, M shell, N shell. It is 4 shells. 4 shells means 4 period. So period is going to be 4. This type of simple questions normally is asked in the exam, which you are supposed to do it. So now, how do you find out the periods? Is basically based on the number of shells. 4 shells, 4 period. 2 shells, second period. 1 shell, first period. Just remember that way. These are the type of normally the questions which you can get. So another particular question which you may sometimes come across. They may not give you a name, calcium or sodium or something. They may just give you an element P. And they will give you an element P has got atomic number 20 or something like that. So automatically they will ask you what is going to be the valency of that, which group it will remain. So you have to find out the electronic configuration. Once again, which group? Since the number of valence electrons is 2, group 2. Period, again 4. There should be 4. Let's take one more example, quickly. Let's take one more example. Let's take something like say Q and let's say Q is 16. So in this case, you write down the configurations 2, 8, and 6. Now comes the catch. Which group? It has got 6 valence electrons. 6 valence electrons, group 16. Which groups? Okay, 6 valence electrons will be group 16. Anyway, group. Another way to find out the valency. Valency in this case is 2. So again, it comes to group 16. So group will be 16. Period 1, 2, 3. So the period is. Remember, this kind of simple, tricky sums may be asked. Thank you so much.